Okay. Um, this is last year's test. Question 4 is remember 4, 5, 6, and 7 are the short ones. So 1, 2, and 3 are like take 22, 23 minutes apiece, and they're 10 points. And then 4, 5, 6, and 7 are a little shorter. And so phenol is a weak acid. Couple reasons. This is a very, very tiny number. Case of A means acid that dissociates in water. And then this is this is Bronsted-Lowry theory, which this is equivalent. Let me just say this. This is equivalent to this C6H5OH. Because it's an acid, we could do something like this. Um, But remember, pure liquids and pure solids aren't used in equilibrium, and this is logically equivalent to this. So the same thing. Um, I actually kind of like Bronsted-Lowry theory because it always works. Arrhenius doesn't work for weak bases. Um, Arrhenius doesn't work for bases because so it always works. Arrhenius is easier, but only works for acids. Okay, so what is the pH? This is a weak acid, which means if you have a weak acid, um, and actually I probably typed this wrong. It's a weak acid. It goes to equilibrium. It should have double arrows there. So what I'm going to do down here is C6H5OH plus H2O liquid, which isn't going to get used. And then we have C6H5O minus plus H3O plus. And so then I set up an ice chart. And then this is 0.75. This is 0. This is 0. These are going to go up X. This is going to go down X because of the 1 to 1 to 1 mole ratio. So up 1X, down 1X. And so then X plus 0 is X, and X plus 0 is X, and negative, or 0.75 plus negative X is 0.75 minus X. All right, sorry I had to stop for a minute. And then I'll just put this over here, not that you probably would need to write this down. Ka is equal to this concentration, because it's right over left, times this concentration over this concentration. And so coming down, I'm going to push extend page. Um, what you end up with is the fact that you would end up with x squared over 0.75 minus x equals 1.12 times 10 to the negative 10. And so I would just put this in my solver. You don't have time on the AP exam to haul out the quadratic formula. My solver, because I have an 84, one side has to be 0. So I would bring this over. And then when I put this into the solver, you end up with x is 9.2 times 10 to the negative 6, keeping 2 sig figs because this has 2 sig figs, molar. If you go back up and look at our chart, X is defined as a H3O or H plus concentration. And so then when we do pH is the negative log of the hydrogen ion concentration or the hydronium ion concentration because they're logically equivalent. pH is the negative log of 9.2 times 10 to the negative 6. And so remember now on pH, this has 2 sig figs. The number in front does not count. It's only the numbers after. So I got 5.04. So that's the answer for A. And then the answer for B is for a certain reaction involving C6H5OH to proceed at a significant rate, the phenol must be primarily in its deprotonated form. In order to ensure that C6H5OH is deprotonated, the reaction must be conducted in a buffered solution. This is the key word, buffered solution. Anytime you hear buffered solution, you have to haul out the Henderson-Hasselbalch equation. And so the pH is equal to the pKa value plus the log of the concentration of the conjugate base over the conjugate acid. On the number scale below, circle each pH for which this dropped out. I don't know why. C6 is more than 50% of the phenol in the deprotonated form. So interesting, this is key. The cut point is 50%. At 50%, let me go back to this equation. At 50%, this concentration and this concentration are the same at 50%. That means you have half this, and why that's important is at 50%, this number and this number are the same, and so this is 1, and then the log of 1 is 0, because you get the log base 10 of 1, and the log base 10 of 1 is 0. So pH is equal to the negative log, because that's what P means, of 1.12 times 10 to the negative 10. And if you do that on your calculator, now looking at this, I know it's going to be between 9 and 10. Sorry, I bumped something on my tablet thing. And so this ends up being, what does this end up? Oh, I end up getting 9.951. This has 3 sig figs, so I need 3 places. And so if you go above, the cut point at 50% happens at 9.951. And so we come up here. And so it would be 10. It'd have to be all the pHs bigger than 9.951. And so they wanted you to circle these 5 numbers. And that's it for that one. And that's a crazy one because Henderson-Hasselbalch bugs you guys.